All right, thanks everybody. So I'm actually a colleague of Jonathan, so his filament presentation there is a nice segue into this talk, which is called the Nucleus Design System. So now we're very much moving into the space of artists. So this talk is all about desktop application software development with a particular focus on graphical user interface design. And along the way, I'm going to describe our journey of discovery at Animal Logic. We're going to be looking at some best practices, design patterns, and frameworks that we've developed along the way, and how this journey culminated in what we call the Nucleus Design System. So, as I said, my name is JP Collins, and I'm also speaking on behalf of my colleague Anno Sharkner. So, Anno and I are software engineers working in the research and development team at Animal Logic. And for many years now, Anno and I have been not just developing applications themselves, but many of the frameworks that underpin those applications. And our learnings along this journey are really what I want to share today. So the way this talk is going to be laid out is it's a chronological overview of some of the key projects that we've developed at Animal Logic over the years and our user interface learnings along the way. So the main body of this slide shows some key timeline projects at Animal Logic, and the vertical axis there is key steps in our UI discovery, starting at the bottom left there with first steps in Qt, more learnings along the way, and culminating at the top there in the orange and yellow bars with the Nucleus Design System more recently in the last few years. And I've also laid these out horizontally as well, so you can see roughly when each technology was incorporated into our technology stack. Now, of course, this is a multi-year, nearly 15 years of development there, and obviously a big motivation of this talk today is to try and encourage people to compress this time frame down into, perhaps a year. This was a long process of discovery. We didn't get to the end by any means, knowing where we were at the beginning. So, in a nutshell, what Nucleus allows you to do is to turbocharge the creation of Qt-based desktop applications. So this is Filament, you saw earlier in Jonathan's talk. It's our standalone Qt application, and it comprises a large number of models, views, commands, context menus, toolbars, all working in a highly interactive manner. And we're able to now, at Animal Logic, create this sort of level of application with this many moving parts with very, very small development teams. And that's a testament to the power of Nucleus. Another flavor of Nucleus is in so-called embedding applications. And this is where we start with a baseline DCC application like Maya, Houdini, or Nuke, and then, or in this case, the RV review system. And then we inject in additional models, views, and commands to augment or extend the functionality of the baseline system. So both of these examples here, the standalone and embedded flavors, are examples of how Nucleus can help turbocharge the development of quite complex interactive experiences. So I want to take a step back and just locate this talk in a bit of context and remind ourselves why graphical user interfaces are so important in the first place. And to me, they're really critical, and it's something I've devoted much of my career to. They're really the central point of information delivery for your application. It's where the rubber hits the road. It's where artists are going to meet algorithms and data, and it's the visual concretization of abstract concepts. Good UI UX is going to lower cognitive load, increase efficiency and throughput, and decrease onboarding time. So there's a host of really great reasons why investing in quality UIs is so important. At the same time, though, developing quality UIs is difficult. There are a lot of resource limitations, notably time, which is often not available in fast-moving production pressure environments. It requires consistency in processes and people, which is not always available, where you often have different teams working in a fairly decentralized manner. And you may have staff turnover between projects, which gets in the way of momentum that you want to create, creating this sort of quality experience across multiple projects. And certainly at Animal Logic, we've hit many of these issues along the way. And this talk today is really our journey of discovery, navigating some of these challenges. So let's now dive back into 2010 when we first looked at replacing WX widgets with Qt. Now, of course, today, Qt is very much at the center of the VFX reference platform, and indeed, many flagship products like Maya, 3D Studio Max, Photoshop Elements, Ableton Live, Google Earth, Mathematica, all built using Qt. But back in 2010, it was much more of a gamble for Animal Logic. We really didn't have much Qt experience in the building at all. But we also didn't have many user interfaces as well, so it was a fairly quick transition from WX widgets across to Qt. Many of you are probably aware of Qt, but if you're not, it's an abstraction layer. It's a cross-platform abstraction layer over native frameworks. And the idea behind Qt is you can write an application in Qt and with minimal code changes, have it run on a range of operating systems. So right from the word go, we began with the C++ libraries, as that was more close to what we were used to. But over time, we realized that the Python bindings really opened up a much wider pool of developers, and we went from dozens to hundreds of developers that could contribute to our user interfaces, and really turbocharged UI development at Animal. So I'd say that we've definitely primarily moved towards Python as our entry point into Qt and application development. One thing to note is that there are two distinct families of Python bindings in the Qt world, the PyQt bindings and the PySide bindings. Substantially, their functionality is identical, but, and we selected the PyQt project because back in 2010, that was clearly the most well-resourced project. More recently, PySide has gained much more resourcing and arguably would now be considered the standard. But what we would say is a key pro tip is use an intermediate facade layer like the Qt Py project. And what this means is that by having this small abstraction layer between your client code and either PyQt or PySide, you avoid having to embed import statements in your source code that nominate either PyQt or PySide. And by using an abstraction layer like Qt Py, you can delegate the specific choice of the Python binding to an environment variable. And we learnt this the hard way because that required us to refactor thousands of modules. I also want to digress and make a small note about Qt Designer. So it's a rapid application development tool in the Qt ecosystem, and the idea is that you can create user interfaces visually and it will auto-generate code for you. Now, on the face of it, this does sound quite appealing, and certainly there was some initial interest in using Qt Designer. What we generally found, however, is that when we auto-generate UI files, they're not really maintainable by hand. You cannot really refactor them, organize them, comment them, etc. And overall, they became a development burden. So we really came to the conclusion that the short-term gain was really not worth it for the long-term pain of a development burden. And overall, we've gradually phased out our use of Qt Designer. So once we had migrated across to Qt, the next challenge was to create a visually unified ecosystem and a visual design language. We really were keen that we had a suite of applications that all had a very consistent look and feel. But more than that, the visual design language aspect means that what we wanted was that consistent concepts like character, prop, shot had a consistent visual representation across all of our applications. And more than that, any auxiliary content like documentation as well. So the first step in this journey was to replace the out-of-the-box Qt look and feel, which you see on the left of the slide there, with something akin to what we see on the right. Our motivation for a light-on-dark theme was that it worked much better for artists in low-light conditions, and also was much more of a natural fit with Maya, Nuke, and Houdini, which generally prefer a light-on-dark scheme. So by tuning the QSS style sheet system, we could generate really nice quality UIs, and our style sheet became universally adopted across all Animal Logic applications. We put time and effort into ensuring that we had consistent use of, for example, blue as our preferred highlight color for selection and other key points of UI display. And so that was a really good first step towards creating a visual brand across all Animal Logic products. We very quickly realized, of course, that there's a huge amount of redundancy and duplication in a QSS file, which is very similar in format to a web CSS file. So we very quickly realized you could take out all those constants and move them to a separate Python module and then procedurally generate QSS files. And this avoided duplication and redundancy of those values. But more than that, it allowed us to readily generate families of QSS files targeting different platforms. So when I said earlier that blue is our preferred highlight color for UIs at Animal, in the case of Nuke, orange tends to be their preferred highlight color. So in our QSS generation, we've got a variant for Nuke, which uses orange as a highlight color. So the next key step was to replace applications delivering their own sort of visual design language resources and instead create a new UI package to really consolidate all of those. Now we happen to use the Res package managing system, but the same design pattern would work regardless. And the key idea there is that applications are now choosing to resolve our common UI package, which becomes a single source of truth for all of our UI-related resources. And this was a great step forward because it meant that any changes to style sheets and so forth would be immediately adopted by all of our applications the next time they resolved that package. Of course, when you move to this sort of model, you do require good communication between the team because the team members managing this UI package and all of the resources in there do have to communicate well with the developers of the applications because changes are going to sort of propagate out into those applications. But overall, we found that it was well adopted and there was desire to use this shared UI package, and we had good development momentum from that. Some other points to note along the way is that typography and consistency of typography is a really important characteristic of quality UI. So we selected some quality typefaces and ensured that they were rolled out on all workstations. We also ensured that we had a common color palette defined in that same UI package. So again, rather than having applications just defining random sort of color constants, we really encouraged them to use the color constants defined in our common color palette. And that meant that we could define certain colors that might represent states like error, warning, information and such like. And again, moving towards sort of a coherent look and feel where the same semantic meaning of color is common across all applications. In a similar vein, icons as well. So rather than applications shipping their own icon artwork as PNG files, we much preferred that applications would use the icons that are also shipped in that same UI package. And over the years, we've developed well over 1,000 icons covering just about every conceivable aspect of the pipeline. What's really nice now, of course, is again, if we modify the artwork for any of those PNG files, that will be immediately propagated to all applications that use that same UI file. I should also point out that we make extensive use of runtime colorization of icons, so we quite often store the original icons as white PNG files, and then at runtime we colorize them as needed. So by this point, and you can see on the left bar there, our gradual journey. So in our journey, we now have Qt rolled out and a consistent visual design language rolled out. So the next challenge is to extend the built-in Qt widget library. So Qt ships with hundreds of battle-tested widgets covering many of the common scenarios. So in these UIs shown here, radio buttons, checkboxes, and push buttons are the standard bread and butter of the Qt sort of ecosystem. But Qt is fantastic. It really allows very easy creation of custom Q widgets through extension, modification, and aggregation. And over time, our developers developed some fantastic extended widgets, such as the color selector on the left there, a file browse box at the bottom, environment list view, jog dial, and actually hundreds of other custom widgets. And this was really fantastic to see. Now, again, we were really keen that rather than applications shipping their own custom Q widget logic, again, we encouraged that logic to move into that shared UI library so that all applications could benefit from these custom Q widgets. And we actually found that even if only one application was the target for any given Q widget, just the work required to tease out and separate the business logic from the Q widget logic was a really worthwhile exercise in separation of concerns. And so usually the Q widget logic itself was improved by separating it out and moving it into that custom library. A small but useful trick I want to mention is the use of the facade pattern. So in Python, you can create modules where you can import from other modules. And we did that. We created a new UI module, and then we imported all of our standard Q widgets and all of our extended Q widgets into that same UI module. And what that really did was replace those difficult to read and use Python paths on the left there with a very simple invocation pattern as seen on the right. So UI.combobox, UI.treeView plus, and so forth. And that meant two things. It meant that it was very easy for TDs to discover and utilize and construct these Q widgets. And it also really consolidated our ecosystem and really erased the distinction between the out-of-the-box Q widget library and our extended Q widget library, leading to a unified widget ecosystem where in this widget browser here, you can see we've got a full list of widgets on the left, and on the right, you can see an instantiation of each one of those widgets. So we now had a unified widget ecosystem on top of our unified visual design language. Whilst we're in the space of widgets, I do want to mention a particular challenge that we encountered working with large UI data sets. So obviously, large hierarchical data sets are ubiquitous in our industry. And at this point, I'll distinguish between lightweight data controls and heavyweight data controls. So something like a combo box, a checkbox, or a radio button is a very lightweight control where it can be pre-populated at runtime sort of immediately. But heavyweight data controls like tree views, list views, and table views, that's not always the case because they can contain potentially just about infinite amounts of data. And we did encounter applications taking minutes to launch because of the huge amount of data we were attempting to pre-populate into the tree control. Now, Qt is well aware of this issue, and they do have a suite of what they call model view components in which they use the dependency inversion design pattern to reverse the normal flow of control. So whereas in most of those simple lightweight widgets, the client code will make API calls onto the widget. In the dependency inversion pattern, the widget at render time will query the client for specific pieces of information. So in the case of this table, for example, as each cell is being rendered, Qt will then query the client for the text, the font, the color of each cell. And that's a fantastic pattern because it leads to deferred data querying, it's much more performant, and it's the way to go. In that example here, we might have 6,000 rows, but we're only going to be asking for the first 6 rows. So fantastic, you say, but the problem is that this is one area where Qt really let themselves down. The application programming model for these model view controls is just very, very difficult to use, and you practically need a PhD to actually work with these. So what we found in practice is the practical usage of these model view components at Animal Logic was sparse to non-existent. So one of the key things we did was to actually subclass all those model view controls and lower the barrier to entry so that we got the advantage of performance, but with a much easier programming pattern. So the key idea was this a data source pattern where you can register row data sources and register 0 or more column data sources. And each data source has methods that correspond to what you see there in white. So row count, header text, text for the ith row, and so forth. Similar for the column. And what this meant was that clients could very easily gradually implement these methods in order to populate the tree view, list view, and table view incrementally with more content and build it out. So very easy to get that full benefit of the model view sort of design pattern. And so that pattern proved to be extremely successful for us, and our Tree View Plus control in particular has become a real workhorse at Animal Logic. You can see here, for example, 6 different examples of the same control, and the key difference here is pumping different data into it via judicious choice of what goes into those row and column data sources. Indeed, we found the design pattern, the dependency inversion design pattern, so useful that we rolled it out in many other contexts as well. So here, when we created a graph view, and this is the graph view you saw in Filament earlier, which we needed for any kind of data that had graph topology, rather than recreating the graph view for every different sort of use case, we found we could introduce a graph view data source and have different clients then pump their data through that data source in order to use the same graph control in different contexts. And that's meant we can use the same graph control in lighting, in assets, in a wide range of contexts. And indeed, again, another great example is with the properties view. So again, a properties view is something which is going to show you key value pairs for a selected object. And whereas previously we might have recreated that control for each different business case, now we can simply use the same properties view control and just simply have clients implement or subclass a properties view data source and pump their own data into that, via that data source into the properties view. And again, what this design pattern has done is ensure that we have a huge amount of code reuse, and any improvements to that properties view only have to be done once, and every client will benefit from that. So a parallel challenge we had along the way was to organize the hundreds, if not thousands, of scripts, tools, and commands that had developed over the years at Animal Logic. And another design pattern that worked really well for us here was the command pattern. So recall with the command pattern, which is a standard Game of 4 pattern, that the key idea is that you have a method like do it, execute, or run, as it might be called, and you put your key payload of functionality, your script or your function, into that method. And then your command has a method, something like ID, which returns a unique identifier, and potentially other methods like UI data, which can decorate that command with titles, tooltips, icons, and so forth. And what this means is that you're taking your disparate scripts and turning them into reusable, discoverable plugins with unique identifiers. And this really opened up the possibility of creating automated tool palettes like we see on the right there with the artist toolbox. So on the left, we see an example of a script that's being promoted to a first-class command. And on the right there, we see the kinds of UIs that can be automatically generated through discovery of commands and then automatic creation of that layout. And what's great now is you need almost no human intervention. If someone creates a new command, it'll be auto-discovered by the system and populated into our tool palettes. Indeed, we found it such a useful design pattern that we found that with applications themselves, we could replace huge swathes of functionality in context menus and toolbars with simply lists of command identifiers. Then at runtime, the system would then consult the command registry for a matching command and then use the command UI data to determine the correct formulation of queue actions to populate the context menus and toolbars. So we now had a situation where we had a shared visual design, a shared ecosystem, and great use of the data source pattern and great use of the command system pattern. But we still had some other challenges. We didn't stop there. When it comes to creating full-featured MVC or model view controller applications, we had Synapse and Ash Designer initially. We found there was a huge amount of code duplication and window management logic that had to be rewritten for each one of these applications. Each one also had a very different internal structure and there was no rhyme or reason, and we felt that we could do better. So a key insight we had was that we could use the same command pattern we saw a moment ago, but generalize that to models, views, as well as commands, and essentially reimagine models, views, and commands and other aspects of a UI as simply discoverable plugins with identifiers and certain key characteristics that could be used by application frameworks. And so what I mean by that is we introduced model factory and view factory interfaces, again, which publish a unique identifier, and their factory creation methods, like create model or create view, would then create the internal model representation or view representation. And so with this, we could really reimagine whole application development as application via configuration instead of application via code. So when we talk about code-free applications at Animal, what we really mean is we can actually define an application configuration there in light blue as a list of model IDs and view IDs and command IDs, and the application, when it runs, they're seen in darker blue, it will consult the manifest here and actually discover the appropriate models and views from the registry, instantiate the appropriate internal data models and views, and then populate your entire user interface without any explicit code at your application level. It's all through configuration. And so that was a sort of a fantastic next step to creating really genuinely reusable components. And it also meant that where any particular application author wanted to improve a component, instead of actually forking the code in their own application, they would then actually improve that component's innate functionality, which would also benefit all other users of that same component. So another key point of these application configurations is that mapping event IDs to command IDs you see down there. And the key idea here is that what you can do, you can promote an internal Qt signal slot or other sorts of event into a first-class event ID, and then what can happen is that the Nucleus application can consult that lookup map and determine if there's any commands associated with that event ID and then execute those commands in turn. And what that does is channel all of the orchestration of the models, views, and commands through a very tight pipe, and it means that it's very easy to rationalize, debug, and understand what's going on in very complex interactive applications. So Nucleus was a really great step forward in creating robust, reusable applications where the actual application framework is the same. So here, what I mean by that is this is Filament on the left, Film Studio on the right. It's the same application, really just configured differently. But effectively, it's two different applications to the artist and the user, but it's really just the one application configured differently. So Nucleus was a really great step forward for us, again, not just for standalone Qt applications, but also applications hosted in DCCs. So for example, Forge here is our animation system, and it's hosted inside Maya. And it's the exact same application configuration we saw before, with the addition that we have some additional Nucleus models that encapsulate the event systems from the host applications so that the host signals can be reinterpreted as Nucleus events so they can participate in the Nucleus event command system. So that was Nucleus 1. So the feedback from Nucleus 1 was really good, and it's rapidly become widely used throughout Animal Logic, and there's dozens and dozens of applications built around Nucleus 1. Now, some feedback we did get is that we did want artists were keen that Nucleus applications could work more nicely with hosted applications. So when we say more nicely, rather than being a separate main window alongside the main window of the DCC, there was a desire that, where possible, we could actually inject our Nucleus doc widgets directly into the mainframe of the host application, along with other elements like menus and toolbars. So we identified 5 key DCCs, namely Maya, Houdini, Nuke, RV, and USDView, where Nucleus 2 was going to really aim to do just that. And so I'm happy to say that just in the last few months, we've really achieved this goal. And so now we have all 5 of those DCCs with Nucleus embedding now enabled. So here, for example, we have Nuke running with the Plasma Nucleus application running inside of it. So we've got Nuke running, but also injected into it are things like USD stage outliners, property views, and production explorers. You'll also notice that orange highlight color there. That's an example of the customized QSS file I mentioned earlier. Another example is RV with our RV Workshop Nucleus application, where again, we've augmented the RV main window there with production explorers, session explorers, and property editors. And again, there's a huge amount of reuse there. The same components that we saw in Nuke and Plasma also appearing in RV and RV Workshop. USDView, again, another example where we've augmented it with the USD Workshop Nucleus application. And again, it's such a seamless fit, you can hardly tell where USDView stops and USD Workshop begins. So we're really happy with how Nucleus 2.0 with its embedding mode has been accepted by the community. So many of the applications I've mentioned just now, Plasma, Film Studio, Filament, and Forge, have all been referenced in previous DigiPro and SIGGRAPH papers over the last few years. So by all means, you can find out more about those. I believe there might even be another Plasma talk in this DigiPro as well. And finally, where to from here? So some of our next steps with the Nucleus framework will be improved documentation and discovery so that clients have a better understanding of the capabilities of each potential Nucleus component in the ecosystem. Improved analytics, performance, and logging so we can better understand who's using components in what context and how well they're going. And also Nucleus for the web. So obviously this talk today has really been focused on desktop application development, but we're moving very much towards the web for many sorts of data, and we're confident that many of the same Nucleus design patterns will work quite well in terms of web application development. So that was Nucleus Design System. Thanks for listening.
While we're waiting for questions, first of all, I'd like to congratulate you on getting all of your developers to adopt the same UI style. I think we all have aspirations toward that, but with varying success. The first question I have is, you've demonstrated a very sophisticated conceptualization of all the different concepts needed to produce a good application. But I imagine you have novice programmers and experienced programmers alike. How much time did you spend educating them about these dependency inverse and command?
Well, it's fair to say that this talk has probably been given informally about 300 times to different developers.
That's what I was sort of thinking, yeah.
Yeah, for sure. I put a lot of effort into the TreeView Plus in particular. Obviously, Nucleus is what this is all about, but that TreeView Plus control was a game changer at Animal. Like I say, no one knew how to use the Q TreeView control and the Q model index and that kind of thing. So I have put a lot of effort into training people on using that pattern. And I think, yeah, it's just the fact that it spread like wildfire, I think is really testament to if you can make something easy to develop against, people will adopt it.
Well, that's wonderful. We have a question over there.
Marco, LM Digital. I had a question about the design by configuration, the application design by configuration. What kind of limitation do you get there? Because I had the impression when you have an interactive application, you have different view of the same data, and the interaction with the data can change a lot the data, and the update of that may be, we had the problem with multi-threading updates of the data in the previous talk too, and maybe you don't want to, you need more fine control, I was thinking sometimes, and did you face any limitation with this design?
Well, just to clarify, when we use the phrase application as configuration, it's something of a conceit. Obviously, Filament isn't 1,000 lines of configuration, it's 100,000 lines of code. So when I talk about application as configuration, I really am talking about the top-level integration of the models, views, and events system into one coherent package. Obviously, at the level that Jonathan talked about earlier with the fine-grained multi-threading and so forth, tends to be updates inside a model's implementation or inside a view's implementation. So when we talk about configuration here, it's really the outermost shell, which is really describing what happens, for example, when you select or drag drop from view A to view B, what's going to be the UI update and that kind of thing. So in some cases you are working at that Nucleus configuration level. In some cases you need to make changes to the internal components themselves. But it is worthwhile saying that, yeah, a key point I wanted to try and make in that talk about the fact that it's code-free is that often what happens is that when you have different applications using, say, shared widgets, it's very easy and tempting to want to take a shared widget and then subclass it and do your own secret sauce. And invariably that means no matter how much you try and organize the cats, the code base splinters out. So by having applications configuration, you almost make that not even permitted. And so the only way you can get additional functionality, you actually do have to force developers to go back to the source component of interest and modify that, maybe make it we do have a degree of flexibility in each, say, view component. So you can nominate view parameters, like do you want to see certain elements of that UI control. So it does mean a bit more effort or discipline because you can't just get what you want for your own application for free. You have to modify the core component. But I actually call that a real strength because I call that floating, a rising tide floats all boats. If you make the change for everybody, then everyone gets your change. And the challenge is always that you've got a lot of really smart TDs that all want to kind of make changes, but for their own applications. So the challenge is how do you corral or focus all that energy so that all the effort that people are doing to improve components actually benefits everybody. So I think Nucleus is at least a good step towards that sort of design pattern.
You don't get conflict in the will of each guy you want to personalize this thing?
Sometimes initially it seems that way, but usually when you get two people talking about what they really want, whether it's an improved status bar or what they might need in the properties view, you usually find a common consensus. Because whilst everyone thinks initially that, oh, my department's special and doesn't need what your department needs, actually it turns out when imaging needs, the properties view to show that a USD parameter is animated, actually it turns out that every other department needs that same kind of bit of information as well. Of course, sometimes you might need to express it in a certain way, and so all of these components do have a degree of flexibility. So each department can inject certain additional metadata and UI icons and that kind of thing that might be more or less relevant to their given department. So yeah, the challenge is always to find that sweet spot between commonality where possible with flexibility as needed for tuning and customization. And it is a constant battle.
Thank you.
All right, I think we have time for one more question. Over there, please.
Thank you. John Rogalski from JW Studios in Watchtower. I just wanted to go back to the visual design language section.
Mm-hmm.
And your UIs always look great from Animal Logic, and you've been doing this for a long time. But I wanted to know if you had any feedback over the years from artists on what worked, what hasn't, that's kind of driven your approach to UX and UI. So less technical, sorry.
Yeah, sure. I mean, look, it's not just me. There's a whole a team of us who work on this kind of thing. The light on dark theme was really popular from the beginning. I have to listen to people's feedback. Sometimes I want to cram a lot into a UI, and so I tend to make the typography a bit too small. And the latest feedback is modern resolution monitors. No one can read it anymore, so I'll have to go back and increase some of the font sizes. Generally speaking, the iconographic design language we tried to achieve for the icon design has been popular because it means that it opens up the possibility for a much wider range of people to contribute as well, because it's more pictographic or iconographic in design as opposed to sort of 3D renders or anything like that. Overall, I'd say that, and we do have an open, people can contribute to the color scheme and things like that. So it's by definition, we don't want to be like a top-down sort of dirigist kind of approach to this sort of thing. It's got to be really collaborative. But generally speaking, if you make something look good, people generally like it and they will adopt it. But I'm really encouraging that everyone contributes to the icon library, the color palette, and so forth.
Thank you.
All right, let's thank the speaker again.